In this lesson, we cover depth of field in Arnold for Cinema 4D. Depth of field is the depth of the area in the render that is in focus. So for example, in this render in the IPR, these cubes here are in focus, and as we move away from the camera, our cubes become more and more out of focus. There are two types of depth of field generally: narrow depth of field and wide depth of field. Narrow depth of field or shallow depth of field is when a very small portion of the image is in focus. We can call this render in the IPR a narrow depth of field. And we have wide depth of field where a larger portion of the image is in focus and the effect is not that obvious. Now, this is the scene we are going to be working with. We have these small cubes. They are about 10 centimeters each. Also, we have this camera 01. And if I go to my top view in the viewport, you can see where is my camera and where is its focus. If you remember from the previous lesson, we mentioned that Arnold can simply recognize native Cinema 4D camera's focus distance. So I can select my camera and from the object tab, change its focus distance, or pick an object to be the focus object, or simply grab this point from the camera and change the focus distance of my camera. Now select the Arnold parameters tag that is applied to the camera. And as you can see, I have depth of field enabled. That is why we are getting depth of field in the IPR. If I disable depth of field, we would get no depth of field and it would be like working with a pinhole lens. Let's enable it for now. The deciding factor on how narrow or wide the depth of field is the aperture size, which is being controlled by this aperture mode. You can see we have 3 aperture mode: size, f-stop, and C4D camera. When the aperture mode is set to size, you get this simple aperture size value to control the radius of the camera's aperture. So the smaller the value, the wider the depth of field. And when I increase the aperture size, depth of field would be narrower and more obvious. The default value here is 1.5 centimeters. At 1.5 centimeters, we get this wide depth of field. Let's increase it to something like 5 centimeters. Now we get a shallower depth of field. Let's try 15 centimeters. And now we get a very, very shallow depth of field. So the larger the aperture size, the narrower the depth of field. You can change the aperture mode to f-stop and control the size of the aperture based on f numbers. The smaller f number means larger aperture size and larger f number means smaller aperture size. Therefore, smaller f number means larger aperture size and narrower depth of field. And on the other hand, larger f number means smaller aperture size and wider depth of field. Just to simplify this again, the smaller and lower your f number, the narrower or shallower the depth of field, and the larger and higher your f number, the wider or deeper the depth of field. So if I change the f number to something like f8, we get a much wider depth of field. And if I try something like f1, we get a much shallower depth of field. And if you still want to get shallower, you can manually type in values that are less than 1. Let's try something like 0.2 for a very, very shallow depth of field. And finally, you can use C4D camera. And in this mode, we can select the camera itself and under the physical tab, control the aperture size with the f-stop values here. For now, let's change the aperture mode to f-stop and use f1 as the aperture size. Let me stop the IPR for now and take a snapshot. Another deciding factor regarding depth of field is the scene scale. If I scale my scene down 10 times, we are going to have a much, much shallower depth of field. And if I scale my scene up 10 times, we are going to have much wider depth of field. From the edit menu, choose scale project and let's convert 10 to 1 and hit OK. I'm going to run the dynamic sim again. And the f-stop is now set to 10 because we increased our scene scale to 10. So let's set it back to 1, which was the previous value. And run the IPR again. You notice we have a much shallower depth of field when compared to the previous render when the scene was 10 times bigger. Let's take a snapshot here as well and compare the two render. So as you can see, compared to the previous render, even though we have the same aperture size, but because the scene is much smaller, we are getting much shallower depth of field. Let's close this window and stop the IPR. And from the edit menu, select scale project and convert 1 to 10. So we have our original scene back. Let me just run the sim again. To see the rest of the depth of field settings a bit better, let me revert to the saved project and look through the second camera. And also we can change the HDR image to the second one and run the IPR. Now we can select the Arnold parameter tag that is applied to our second camera and take a look at the rest of the parameters. I want to focus on the environment, so let's draw a render region here. We have aperture blades, which is the number of blades of the polygonal aperture. 0 is considered a circular aperture. Now if I set it to 3, we're going to have a triangular aperture shape. And at 4, we get a rectangular aperture shape, and so on. Set it to 3 for now. Aperture blade curvature controls the curvature of the polygonal aperture sides. 0 means hard straight sides, and increasing this value results in progressively more curved edges. And at something like 1, we will get perfect circular aperture sides. And negative values will create pinch aperture sides. Set it to 0 for now. Aperture rotation allows you to rotate the aperture. Let's try 20 degrees, 40, 50, and so on. So as you can see, compared to the previous one, we have rotated the aperture and the triangles are looking another way. Let me disable render region and get back to the first camera and use the first HDRI image for the environment. I'm going to select the parameter tag for the first camera, set the f-stop to around 0.35. And we have aperture aspect ratio to simulate anamorphic lenses. Higher values than 1 will stretch the defocusing effect and lower values squash it. Let's set it to 0.1, 1, 2, and 4. For now, set it to 1. Now, if I wanted to alter the focus of my camera and focus on the cubes in the back, we can set the IPR's camera to camera 01 so it won't change. Now I can simply go to the top view, select the camera, and let's change the focus distance of the camera back to here. And now we have altered the focus of our camera and the back cubes are in focus. Let me press Ctrl Z to change the focus distance to where it was. And I'm going to set the f-stop to around 1.1. It's fairly hard to clean up renders with very shallow depth of field. The only solution to get cleaner renders is to increase the camera AA samples to higher values like 7 or 8 or even higher. Probably 7 would be enough for this scene, and the remaining noise can be dealt with Arnold Denoiser. This is the render I have with camera samples set to 7 without denoising, and this is the same render after denoising. You can see it's very, very clean. But obviously, when you increase your camera samples, you're going to get much longer renders. But on the other hand, remember, when you increase your camera samples, you can decrease your diffuse and specular and probably transmission and substrate scattering samples. But this would be enough for now. So in this video, we learned about depth of field in Arnold for Cinema 4D. See you in the next video.